Hello guys, this is Prajwal. How are you guys doing today? Today I'm here with a very interesting topic called principal component analysis. If you've not read about PCA, so I would suggest you go read first and then you can come and watch this video, as these codes will be extremely clear for you. So we have worked this in our college in a group of two, and sitting right besides me virtually is a Sarang. He's my colleague. Me and him both will explain it to you. So let's go. So I've named this function PCA or compressed. You can name it anything. And this function takes 6 arguments. So the first argument is image, and that is the name of the image which you want to compress. Directory is the path where you want to store the image and where the actual image is stored. Folder name is the path where the compressed images will be saved. It will be saved inside this path in a folder that will be named grayscale image. If you want to save the grayscale image, the default value is no. If you don't, it will not save the grayscale image. If you want it, you can give it a yes. Delete is whether you want to delete the original image. If yes, you can give it a yes. If no, it can be n. And the clarity is the variance. In simple terms, variance is the clarity of the image you want. Like for if 100% is extremely clear, so how okay are you with less clear images? So you can give it around 95, 99, whatever suits you. So I've imported library jpeg here. So what it actually does is it will help me to read the image file. So I will first run this function. So now let me run this function as well. So the image name is dog, and the directory it will be saved in is the same one that the image is actually in. The folder name I've given him as doggy, and I'm saving the grayscale images as well, and I'm not deleting any original images. And the clarity I want it to be is 99.5. So let me go to that folder. This is the folder where the original image was saved, and these are the grayscale images. So you can see all the 3 grayscale images, and this is the compressed image of the dog file. As you can see, 99.5, it is this clear. So how it actually does is, let me run through the code and explain it to you line by line. So after importing the library, the directory will be set as a default directory. The image file you have given will be stored with an extension .jpg in the variable called img, and it will check if you have provided the delete option as yes. If you have provided the delete option, and there might be a mistake here that you don't want to delete the original image, but sometimes it happens that you just overlook it, so you don't want to delete the image. So I have given this another warning that are you sure you want to delete the original image. If you go ahead with yes, only then it will delete the original image. So now I'm extracting all the grayscale images. If the argument value is yes, it will save the grayscale image with an extension of .jpg. Next, what I've done here is I have extracted all the principal components of R, G and B individually, and I'm checking their cumulative. So the cumulative is sum. So it will show me how much distribution of variance is in the first principal component, second principal component, third principal component in a cumulative way. So the next part will be explained by my colleague Sarang. We have worked on this together, so I'll hand him the mic now. So Sarang, here you go.
Thank you, Prajwal. I'm going to continue from here. So we have created these 3 vectors. These are empty vectors created to store the number of principal components which we are going to use. Here, we are going to take the number of principal components till which the amount specified by the user is satisfied. And then we are going to store that number of principal component in this p variable. For example, if the user has entered, he wants 95% of variance, then this loop will run till it encounters 95% of the variance or the closest number to it, and then it will store the number of principal component after which it was encountered. After doing that, the number of principal components required in these variables, and then we check if these above variables are empty or not. Even if one of these variables is empty, we are going to prompt this message to the user, as this is the only case when the principal component will not arrive in these variables. After doing that, we are going to take the number of principal components and we are going to matrix multiply it with the transport of the rotations of the principal component. Why are we doing this is because we are going to revive the original image, and this particular matrix is an orthogonal matrix. That's why we are going to take its transpose, because we want inverse of the matrix. This gives us the grayscale image with the amount of variance specified by the user. After this, we are going to perform some corrections in the image. This is done to remove any inconsistencies between the different views of the image, as all the 3 dimensions of the image will be combined in this code afterwards. So what we are doing here is, if any value in R is greater than 1, we are just going to take it as 1. And if any value in R is greater than 0, we are going to just take it as 0. This is done to all the 3 dimensions of the grayscale image. Then we combine the grayscale image on the particular dimension we want and save it in this variable. Now this part of the code is just to create a folder in the given directory. We are going to take the folder name from the user, the directory mentioned by the user, and we are going to create this folder in the directory specified. After making the folder, we are going to write this image, convert it into JPEG, and going to store it in the given folder. This if statement is to double check if the user really wanted to delete the original image from the folder or not. And if yes, then this particular function is going to do just that. So that is it for the function. Let's test it. I've already run the function. We are going to take this image from the directory mentioned. We are going to say no to the grayscale image and we don't want to delete the original image. We are going to specify the variance of 99.6% and the folder name is going to be rickety. So let's run this function. As you can see, the function has run successfully without any errors. It has not asked me for my final confirmation to delete the original image, as I have already given here no. If it were Y, then a code here would have prompted for my final confirmation. Let's check our image. So this was my original image. This is the folder which we created, rickety. And this is the final image which we get. As you can see, it is a bit blurred and is not as clear as the original image because it only contains the 96% of the variance of the original image. That is it for the PCA function. Thank you for watching, guys.